Ladies and gentlemen, this is a quick run through of shear and moment diagrams. So this is from the example that I did in the previous video, and this is the shear diagram that I put together. The things you need to identify are these numbers here. From 0, it goes up to 952.5. It drops down at the rate that the beam is massive. So it's 80 pounds per foot, so we go down 80 pounds every foot for 6 feet, and then that brings us to 472.5. Then we drop straight down with the point load, and that's 500 pounds, takes us to negative 27.5. And from this point to the other side, it's dropping 10 feet, or over 10 feet, it's 80 pounds every foot. So it drops another 800 pounds, bringing us to minus 827.5 pounds. And then the last reaction force is going up back to 0. So if you start this adventure out and it ends up back at 0, so you begin at 0, go up, come down some more, and then go back up to 0, then you know you did it right. The second part is finding the area. Really, let's simplify this. We're going to find the area under this side of the curve. So from 0, it's going to go up and until it crosses the 0 line again. And that's just going to be some basic geometry, and we'll get a number there. So we're going to follow this line, and we will put that point right here. So right there, I found that the moment at this point was a positive 270 or 4,275 foot-pounds. And I added in some parabolic curves from here from 0 to there, and from there back down to 0. All right, so I have some notes here about how I got these numbers. So the first drop is going 6 feet, losing 80 pounds every foot, and that's how I found that 472.5. And then I took that minus 500 to get to the negative 27.5. And then it goes 80 pounds for 10 more feet, starting at minus 27.5 down to negative 827 pounds. And then we go up from that to 0, and that's how we get that line. To find the area under the first part of the curve, we'll just say the left side. We're just using the area of a rectangle and areas of triangles. That's the only shapes you're going to see in the ones I'm giving you. So we have to find the triangle at the top portion. So think about this triangle right here, and then the rectangle shape there, and then we can add those two together. Some of you may have a little triangle right here where it crosses the 0 line further out, so you'll have to find the area of that triangle as well. So, but what we find there is that you find the area of the triangle, and you find the area of the rectangle, and then you add those two together, and that's how I found the total moment, which is the area under the curve. Basically, we're doing an integral with a graph, okay? And then we draw in the parabolic curve from 0 to that moment, and from that moment down to 0 again. So I ran a computer simulation of these same numbers, and this is what it looked like. So here's the shear diagram, and you can see we have that same shape. All of your drawings will be very similar to this. It will cross 0 at different places. And then we have a moment diagram that's very similar. So you can see how it's a slight curve and then a parabolic curve. So we have two curves. These are not straight lines, these are slight curves. I'm mostly interested in that maximum moment. And if you can identify that, I'm going to be very generous with these lines as long as they're sort of curved. All right, that's all I have for now. Thank you for watching.